This lesson is on the graphs of the tangent and the cotangent. Here's the table for y equals the tangent of x. These values have all come from our unit circle. When you're graphing the tangent function for me on the test, the three critical points that I'm interested in you being sure that you know and graph are negative pi over 4 and negative 1, 0, 0, pi over 4, 1. Be sure that you understand that what we're doing here is we're taking the negative pi over 4, putting it in for theta, and saying the tangent of negative pi over 4 is negative 1. Taking the 0 and substituting it into the function, the tangent of 0 is 0, and taking pi over 4 and substituting it in and getting the tangent of pi over 4 is 1. These are the important points that I want you to be sure that you can graph. The next thing that I need you to be sure that you understand is that the period of the tangent function is pi. This is different from sine and cosine. The period is pi. I also want you to be sure that you understand that the tangent is undefined at all of the odd multiples of pi over 2. For our graph, the one period that we're going to graph on the test, our undefined places on this graph are going to be at negative pi over 2 and pi over 2. So we're going to graph the tangent function now. Negative pi over 2, 0, and pi over 2. I'm also going to need negative pi over 4 and pi over 4. I know that my asymptotes are going to be at negative pi over 2 and at pi over 2. And then I'm going to graph the points that are the critical points that are on my table. Negative pi over 4, negative 1, 0, 0, pi over 4, 1. I'm going to understand that my tangent function is going to approach this asymptote, getting closer and closer to this asymptote, but never touching it. It's going to come up and go through this point, which is negative pi over 4, 1, through 0, 0, through pi over 4, 1, and then it's going to continue up, getting closer and closer to this asymptote. That's the period that I want you to graph for the tangent function. Now, you probably understand, I hope, that the next odd multiple of pi over 2 is 3 pi over 2. There's going to be another asymptote there. Halfway in between pi over 2 and 3 pi over 2 is pi. So you're going to see another one of these exact same shapes, this tangent here. Okay? The same thing would happen going back this way. The next odd multiple of pi over 2 is negative 3 pi over 2. Okay? And this is going to be negative pi right here. And we have another tangent function there. This tangent function is going to repeat itself over and over and over again. Remembering that the period of the tangent function is pi because half of a pi plus half a pi is whole pi. Okay, so that's what I want you to do when I ask you to graph the tangent function. Okay, now the next slides on the PowerPoint are what I've just done here. So here is my tangent function, okay, just like we've graphed here on the paper. Okay, remember that your quotient identity, the tangent of x, is the sine of x over the cosine of x. That's why at negative pi over 2 and positive pi over 2 we have asymptotes, because the sine at pi over 2 is 1 and the cosine is 0. That's why 1 divided by 0 is undefined. And the same thing happens at negative pi. When you think about the unit circle at negative pi, the sine is -1, the cosine is 0, so we're undefined at negative pi over 2. Okay, these are the characteristics of the tangent function. The domain is the set of all real numbers, except for the odd multiples of pi over 2, because that's where our asymptotes are. The range is all real numbers, because this function goes down forever and goes up forever. The tangent is an odd function. That means it has it's symmetric with respect to the origin. Okay, the tangent function is periodic with a period of pi. The y-intercept is y equals 0 right here, and the x-intercepts are at points like negative pi, 0, pi, 2 pi, any integral multiple of pi. The vertical asymptotes occur at the odd multiples of pi over 2. Now, what do you think would make the vertical asymptotes change? What kind of transformation would make these vertical asymptotes change? Think about that and see if you can come up with an idea. Pause the video, think about it for a moment, and see if you can come up with an idea for that. Okay, what would make the vertical asymptotes change? If I were to shift things left and right, then the vertical asymptotes would change. So a horizontal shift would make the vertical asymptotes change. All right, the next thing we're going to do is look at the graph of the cotangent function. So I'm going to slide this up just a little bit. So the graph of f of theta equals the cotangent of theta. Okay, on the PowerPoint here you can see the table of values for the cotangent. Notice that these come from your unit circle. So at 0, we're undefined. At pi over 4, we have a cotangent of 1. At pi over 2, we have 0. At 3 pi over 4, we have -1. So let's draw the table that we want to learn. Okay, so theta, f of theta. Okay, at pi over 4, we have a value of 1. If I substitute pi over 4 in for theta, the cotangent of pi over 4 is 1. If I put in pi over 2, then the cotangent of pi over 2 is 0. If I put in 3 pi over 4, the cotangent of 3 pi over 4 is -1. So I'm going to use this information to help me graph my cotangent. Now there are a couple of things that I want you to remember. Again, I want you to remember that the period of the cotangent is pi. I also want you to remember that the cotangent is undefined at 0 and pi. We're undefined at 0 and pi. So at 0 and at pi, I'm going to have asymptotes. These are the places that the cotangent is undefined. Then I'm going to graph these points right here. So halfway in between 0 and pi is pi over 2. Pi over 4 would be halfway in between 0 and pi over 2. And 3 pi over 4 would be halfway in between pi over 2 and pi. Now I'm going to plug in my values here, substitute them in. So at pi over 4, I'm up here at 1. At pi over 2, I'm at 0. And at 3 pi over 4, I'm down here at negative 1. And just like my tangent function, my cotangent function is going to get closer and closer and closer to this asymptote. It's going to come through these points. It's going to move closer and closer and closer to this asymptote. Okay, that's not a beautiful picture. I apologize for that. I should be on graph paper. Okay, so there is my cotangent function. Notice that the shapes of the tangent and the cotangent are similar. It's just that the tangent, let me do it this way so you can see it, the tangent goes from the bottom on the left to the top on the right, and then the cotangent function goes from the top on the left to the bottom on the right. Okay? Notice that from 0 to pi, that is pi units. If I wanted to come back this way and say here's negative pi, there'd be another asymptote here. Okay, here's negative pi over 2. Here's negative pi over 4. Here's negative 3 pi over 4. And I could draw another cotangent function branch of it right here. Okay, it's just going to repeat itself. It's going to do the same thing going this way. Okay, here's negative 2 pi, another asymptote. I'm sorry, why did I put negative? Sorry. That's positive 2 pi. Another asymptote here. Halfway in between 1 pi and 2 pi is 3 pi over 2. So there'd be another cotangent right there. Okay, this is the period that I want you graphing on the test for the cotangent. This is the period that I want you graphing on the test for the tangent. Okay, so there's your picture of the cotangent function. That's a little bit better than what my drawings look like. That is the reciprocal of the tangent. Okay, and I hope this has helped you to graph these tangent and cotangent functions. You're also going to use your transformations with these. So practice that. Go do your homework.